All right, Alan, it's all yours.
All right. Thank you. My name is Alan Friedman. I'm the Director of Cybersecurity Initiatives at NTIA, which is a tiny part of the Department of Commerce. Once long time ago, I used to be a computer scientist. I wasn't very good at it. So I became an economist and wasn't very good at that. Dabbled in computational modeling, wasn't very good at that. When you're mediocre at that many things, you sort of end up in Washington, D.C. And so for the last 4.5 years, I've been at the U.S. Department of Commerce trying to tackle some of the areas around cybersecurity that we might call market failures. How can the market provide better security for all of us without having government to actively intervene? And I'd like to talk today about an initiative that we've been running for about the last 10, 11 months on software bill of materials. And today I'd like to talk about why we think this is a great idea and potentially how you might be able to get involved. So first today, the important question is, should I bother to pay attention to the video? We're going to talk about transparency. We're going to talk about the supply chain. We're going to ask the question, why aren't we doing this already? And then we're going to talk about what the US government is doing to try to help this with your help. And so we can make a progress. So for those of you who aren't car aficionados, this is a Mercedes S-Class. And it's a nicer car than I can afford on a government salary. And what's remarkable about it in this context is a few years ago, Mudge, the great hacker and security expert, tweeted that if you have a 2013 Mercedes S-Class, it comes with enough software on board that includes libtiff, netcat, and libpcat pre-installed. And if you follow along with your libraries, you'll know that libtiff is very vulnerable, netcat allows you to move around, and libpcap allows you to exfil a lot of interesting things. So the joke that Mudge set us up for is your brand new Mercedes would have come pre-owned. And there's real value in actually knowing, no pun intended, what's under the hood of our software. And in fact, in most areas of our economy, we have a certain amount of transparency. So for example, you can't go to the store and buy a piece of candy without it coming with a list of ingredients. Here are all of the things that we're using it. We don't tell you the recipe, we don't tell you how to make it. We just tell you what's in it. And perhaps most of the time you don't care. Up until, say, you have a good friend with a serious allergy, and then all of a sudden it's very important for that data to be there, for it to be accessible, and for it to be accurate, so that you can make the appropriate risk-based decision. You can sort of begin to get why this is important in software. But it's not just in food, it's not just in consumer goods. In the commercial space, we already do this. If you have a warehouse and you get a pallet full of 50-gallon drums of chemicals, it's going to come with something called a safety data sheet, which is going to contain a lot of details about what's in this. This is an international standard, it's an ISO standard, and it's something that we all do to make sure that our market can thrive efficiently without sacrificing all of the power that goes into the proper amount of trade. And in fact, the term software bill of materials comes from a bill of materials. So if you were to go and buy a 17-ton diesel generator today, it would come with a bill of materials, a list of all of the hardware parts that are involved. Because when you took ownership of that, you would need to know a little bit about the maintenance responsibilities. So you'd get a list of every nut and every bolt so that you would know how you could maintain it. But that generator today is probably going to be running a lot of software. It's probably connected to the internet even. And what's scary is you don't have that same level of transparency into the software that's running your generator. And it could be fine. It could be wonderful. It could be the best software in the world. But it also could contain some outdated components that are exposing yourself to exploits that are widely deployed today. So we have this vision of saying, let's have some transparency. Why don't we have this for software? Well, another way of thinking about this is by creating a data layer, we can have a common set of hooks on which we can build a lot more new and interesting tools. So CVEs, right, the common vulnerabilities and exposures, that's run by MITRE with the help of NIST, my Commerce Department colleagues, they aren't magical. All they are is a way of capturing a certain set of data so that organizations know how to handle it, and a host of vulnerability management tools and services now exist to hook onto this data stream. And that's really our vision here, is to create this data layer on which we can have further innovation to thrive. So it's important to acknowledge that this just isn't the software that's going to end up at one part of the ecosystem. We think of this as a supply chain, right? You have small parts, often open source. They get assembled into compound parts. Maybe they're open source, maybe they're proprietary. And then you might have a final goods, which again, could be an open source operating system or could be a commercial piece. And then finally, that's used by the operator. And there's real value in tracking this data across the entire supply chain. For those of you who are fans of supply chain theory, going back to Deming, the pioneer of supply chain efficiency with Toyota in the 50s and 60s, we talk about supplier selection. Which supply do I use? We talk about supply selection. What do I select? And then vigilance of my supply, making sure that I'm monitoring it for quality. This applies to software as well, but we're going to adapt it a little bit to think about 3 different perspectives across the supply chain. There are those who produce software, there are those who choose software, what software I do, and then finally maybe your operating software. And transparency can really provide great value across the entire supply chain. So suppose you're in the business of making software, and if you're working with this with Nexus, chances are that's a significant part of your role. Well, first, the most obvious approach is just being able to monitor for vulnerabilities in your components. If you're not tracking what you're shipping, you're not doing a great job of shipping a quality product. And it can also lead to much better management of your code base by having a centralized way of thinking about it. You can better execute if you have a list of banned components, or we can only use this type of component. But it also gets to some of the longer term issues. If you're thinking about a component is going to essentially end of life. It's no longer going to support, for example, single-threaded hardware. That's really important for you to know if, in fact, you ship a product that involves a single-threaded chip. Can minimize code bloat. We've heard many stories of very large enterprise products shipping with multiple different versions of the same library simply because they didn't have that internal coordination. License obligations are, of course, something that we should all be paying attention to. And also, there's great value in just being able to signal, hey, listen, I'm aware of what's coming out of my shop. I know what is going to my customer. And in fact, we have a great use case of a major American financial institution that would ask for an SPA as part of their initial purchase negotiation. And if the supplier of software couldn't provide that, the bank would take 10% off their asking price off the top. Now, why did they do that? It wasn't that the bank had the ability to process all this data inherently. They didn't have a specified format for how the data would be transmitted. It could be in PDF. They just knew that if a software company couldn't actually track this data, their overall maintenance costs were going to be sufficiently high that they could justify demanding a lower price, which comes out of the producer's bottom line. Now, again, this goes back to the story of choosing software. So again, if you're someone who is either buying software or maybe you're selecting an open source component to move further downstream, you want to know what the vulnerabilities are. You want to be able to say, I have visibility into here, I'm going to do more security analysis here. So for example, a number of organizations will take a library and they'll just rebrand it. They'll say, this is now, Acme OpenSSL, and we're going to maintain it internally. Well, maybe that's an area where you want to do a little more due diligence because it's potentially forked from the main support line. You can verify sourcing, you can verify compliance. Again, thinking about end of life, there are a lot of approaches here that it can help if someone is in charge of the acquisition side of software. And then finally, if you're operating software, if you're one of the people whose job it is to keep your organization safe, you're maintaining it, the primary gorgeous benefit of this is vulnerability management. When a new vulnerability is announced in an open source component, you don't have to wait for your supplier to tell you whether or not you're affected. You can identify that at the moment. There's a great story from a major hospital when WannaCry was racing across the internet. And this hospital is fortunate enough to have a decent security team. And the CISO had to pull the entire security team off the line and have them frantically call the manufacturers of all of the medical devices, the blinking boxes that's keeping grandma alive, and say, for God's sake, does this thing run on Windows or Linux? Because they didn't have that information at their disposal. Now, the kicker of this story is one of the medical device manufacturers, because it was a low-level support person, gave the wrong answer. They said it was Linux. It was actually running Windows. it was vulnerable, and it was also unpatchable. Now, that also sets up another approach for thinking about what you can do with this. So you can think about non-software-based mitigations. Suppose you're not ready to patch, it's too system critical, or maybe the patch just isn't available. The vendor is no longer in business. Well, you can also consider non-software mitigations if you have visibility into the risk. So you can do some network segmentation that may be a little less efficient, but you can optimize. You can do some tuning of your IDS or IDP. There are lots of other options you can explore to think through how you can help us. So it really does we've made the case that essentially transparency isn't just about one part of the ecosystem. It can help the folks who produce software, who are selecting software, who are maintaining software and operating it for their organization. So that raises a really important question. Gosh, Alan, if this is so useful, why aren't we already doing this? And I think there are a couple of good reasons. First is our friend Richard Stallman. Now, I have great respect for the Free Software Foundation. We've done some work with them in the past, but the JPL license is something that has really thrown the commercial software world for a loop for the past 20 or 30 years. And it's not clear, even 2 or 3 years ago, how many major companies could honestly say that they weren't shipping any GPL code, that they had the full licenses and rights to ship software that was built on all the components that they were using. Today, I would argue that risk is much better understood. We have source composition analysis tools that can answer the question for you. It's something that general counsels are much better educated about and are paying attention to. If you're a startup, this is part of every exit plan, is making sure that you have the full rights to your software. So I think this obstacle isn't really there anymore. Second challenge is, listen, this is really hard. And I'll get into some of the challenges of thinking this through, but one of the basic examples is if we've never done this before, understanding what does it mean to share this data requires some decent understanding. It requires organizations who aren't doing it to invest a little bit, but it also requires some coordination and some standards that I'll get into. There's also, some real obstacles in terms of how organizations operate. So some of you know this logo on the slide. Think to yourself, hey, what is the company and what is the product that feather represents? Well, 10 of the biggest companies that are already tracking their internal software got together and say, hey, what do we call this product? And it turns out of those 10 companies that already kept data on the systems, they were using 5 different names to track this. Now, if we want automation, we've got to find a way to make sure that those 5 different names, Apache 2, Apache Web Server, HTTP2, those are all things that we recognize as the same product so we can track it and do it efficiently. So naming is hard, and I'll get into naming in a little bit as well. But perhaps the biggest obstacle for why we don't do this today is just we've never done it. I would argue this is a chicken and egg problem. No one asks for it because no one provides it, and no one provides it because no one asks for it outside of very limited areas. So whenever we have an example of markets not providing something that we think might make everyone better off, classic economics term for that is a market failure. And a market failure is often a chance for government to get involved. So enter your friends, the feds. That's the Department of Commerce right here in Washington, D.C. My office is just around the 3rd column from the left. So what do we mean by dealing with this? So how does government usually solve these problems? Well, sometimes we regulate. Right? We just say, hey, now everyone has to do this. But there are a couple of flaws here. One, we don't know how to do this. And in general, it makes for very bad regulation if we say, hey, everyone do a thing when there isn't an accepted practice of solving that thing. And 2, also, no one gave me the ability to regulate. NTIA doesn't have regulatory authority. The Department of Commerce in general doesn't do much regulation. So even if we wanted to do something, Congress hasn't given us the authority. Now, the other way government can act is we can pay people to do things. And unfortunately, no one gave me a budget. Otherwise, I'd have a much nicer office. So what do we have if we can't force people to do things, we can't pay people to do things? We have convening. We have this notion that we call the multi-stakeholder model, where we try to bring together experts from across the ecosystem who all have a stake in the outcome and say, hey, let's talk about this. Now, it's not always the most efficient process. If you're used to writing code for a living in an agile environment, it's going to be a little slow. On the other hand, if you've ever been in a standards development process, it is actually a little more efficient than something like that because we're trying to solve a slightly narrower and more specified problem. So we've brought together a wide range of participants, not just the folks who build software, but the folks who use software and select software as well to make sure that we're trying to capture this and prime the pump. The analogy I like to use is suppose we want to get a bunch of kids into a pool. No one wants to be the first one in the pool. We don't know, right? It doesn't look cool. Again, classic government solutions are to run around pushing children in the pool or to bribe them in. In this case, the better analogy is we're encouraging people to hold hands and count, and then they can all get in together. We haven't forced anyone to do anything. We've just been the catalyst for better industry action. So I want to be very clear what we're not doing. This is not about regulation. Right? We are not we're not in that game. We're aware that it might be used in regulation down the road, which is why it's very important for us to have industry at the table, making sure that what comes out of this process actually meets the needs, actually addresses serious risk. We're not about source code disclosure. The Department of Commerce is strongly against any laws or policies that require source code to be turned over, especially to the government. And also, we are not a standards development organization. We are not creating a new standard. What is the problem we're trying to solve? We're trying to address the challenge of complex software supply chains and provide greater transparency into the composition. And this can have some real benefits. Transparency, as I mentioned, can help with the identification of vulnerable systems. It can help you identify suspicious software components. It can make your work more efficient. It can make for a more informed market in terms of selecting quality security and quality processes. And it can reduce duplication of effort by standardizing formats around transparency across different sectors. This isn't just for web development. This isn't just for services. This isn't just for traditional enterprise software. It's not just for healthcare. It's not just for automotive. It's not just for national security. We have folks from all of those communities at the table because this is only going to work if we can actually bring everyone to move together. So our goals: harmonization of different thoughts. Let's amplify and routinize what we're doing, and then slowly move forward towards extending the model and driving innovation from the services that are going to actually provide these solutions here. So we're making pretty good progress. We started this at the very end of the summer of 2018, so 10 or 11 months. We've gotten strong buy-in from a bunch of different sectors. Not everyone, but we've got a lot of buy-in. We have a good appreciation of the scope of the problem. There's a focus on saying, let's come up with an initial basic solution today, and then we'll extend it in the future. And of course, there's an appreciation that there has to be machine readability, right? If this is something you're doing in PDFs or in spreadsheets, you're doing it wrong. So we've tackled this in 3 separate channels. So we can think of this as, what is an SBOM? Why should we SBOM? And how do we SBOM? So let's say, what is an SBOM? This has been a surprisingly challenging problem. A lot of folks showed up who've been thinking about this for a while, and they had the idea in their head. But actually building a detailed whiteboard that covered most of the use cases we were interested in was a bit of a challenge. So we're starting with very simple definitions. We're focusing on baseline or minimum viable identity. At its core, the challenge of tracking components is tracking identity. Now, this is a hard problem. As I mentioned earlier, naming is a known hard problem. And we're tracking some solutions on that. The simplest way to illustrate this is, does your product use com.sun.java or com.oracle.java? Right. Depends on when you started keeping your records. There are always going to be new products. There is always going to be mergers and acquisitions. Names, the namespace is never going to be stable. We've solved the namespace in the digital world globally exactly once. That requires a nonprofit based in California and a global governance structure. I'm, of course, referring to ICANN and DNS. So we'll get there eventually. But the real here is to say component identity is built on understanding the supplier, the version, and some sort of hash or signature so that we can validate that this is, in fact, the piece of software used. And the goal is to map outside data, such as a vulnerability catalog, to the component. That way, we're not putting permanent data like vulnerabilities in the library, because that's always going to change. And so we want to make sure that we have a stable list of the component identities that's up to date. So when the version changes, you can change your SBOM, and then you can map to that. So that's how we think about the components. And we think of these components in a graph or a tree, right? This is my software. It uses these components. Each of these components uses further components in turn. And thinking about this as a tree helps us actually map where our dependencies are. The first question is, how many levels deep do we go? The ideal case would be to get all the turtles all the way down. As one person put it, I want to know what's in my product down to the sand. That is a wonderful goal, and I think we have to get there in the long run. However, that puts a really high cost on the early adopters. And so our approach at the moment has been to say, let's start with a recursive approach where everyone has to get at least their top level dependencies. And then we can go back and encourage them to work with their suppliers to get their dependencies, and so on up the supply chain. Again, whether it's commercial, whether it's open source, that's the goal here. That also means we want to be clear about opacity. So suppose I have two components. A dependency tree will allow me to see when I know all of the underlying blocks versus when I know that I only use one component, but I, at the moment, don't have information about what's in there. That means I can start to make better risk-based decisions. Do I still want to use this component? Do I want to set up some monitoring or surveillance? And so on. So obviously, we've got a white paper that we can circulate if you're interested. I have some contact information at the end of this talk on some more details around this. But I've already talked a little bit about why we should SBOM. And I think it has to deal with these three perspectives. It really is going to create benefits for those who are producing software. You can better understand what you're shipping for a variety of reasons. And it's going to drive a better marketplace as people select their software, again, from commercial or open source. And of course, for those who operate software, it really can facilitate your long-term maintenance in a way that we think can be a game changer. So the important thing, as I mentioned, is that it has to be machine readable. So how do we SBOM? Again, we are not a standards development process. We're not interested in creating a new standard. We know how long that sort of thing takes. Now, the good news is that there exists at least one protocol that can do this, because again, at its core, SBOM is about tracking, here's a component identity, and here's how it relates to other things. The slightly less good news is we have more than one, but we have two. So on one, the two we have are SPDX and SWID. So Software Package Data Exchange, developed by the Linux Foundation. It was initially developed to track licenses inside the open source community, because again, it's very important to be able to track how licenses interact in a given project. But it has since been expanded to a number of different use cases. And there are tools out there today, and it is something that is evolving. It's a live standard, so it has that benefit. And here's an example of what this looks like. Again, very high level, and you can check out the SPDX GitHub if you want to learn more. There is also software ID tags, or SWID tags. They also were developed by the licensing for licensing purposes, but out of the commercial world. So if you're a large organization, you have a bunch of different pieces of software, how can you automatically track the licenses so you can make sure that you're complying to all of your licenses? This is from a user perspective. Think of it an inventory perspective. Now, this is the benefit that it's already an ISO international standard, standardized in 2012, updated in 2015. While the standard itself is not freely available today, the spec is available. I believe you can download the schema. And there are also a number of online freely available resources around this, including a very good NIST guidance on how you can use SWID tags for license management and for inventory management. Both SWID tags and SPDX can be used for the SBOM use case, because again, their goal is to say, here's this piece of software, here's how it relates to other things. and they're both meant to be in markup so that you can track things and identify them and have them evolve over the life cycle of your product. Our goal here is not to pick a winner. Right? That's not the government's role. What we've done is identified the common elements between these two formats, and we are going to have a bilingual ecosystem. Anyone can select what's right for them. We're aware that folks are going to have their favorites for whatever reason, and the goal is to make them as interoperable as possible so that we can maintain machine readability. And if your suppliers are giving you SBOM data in two different formats, you'll be able to convert it and pick the format that's right for you. There's some related efforts in the ecosystem that we've gotten some input from, including the Software Heritage Index, package URL, and the common platform enumeration that NIST maintains. Now, the final thing I want to quickly touch on is, in addition to the what, the why, and the how, we also recently completed a proof of concept in the healthcare sector, where a handful of medical device manufacturers and a handful of very good hospitals got together and said, hey, rather than just talking about this in conference rooms, let's try to do it live today. And so they generated the data, they shared it, and they were able to execute on a number of predefined use cases. And the very short summary of their initial findings is we were able to do it, but we weren't able to do it in as automated a fashion as we had hoped. And so that's why we want to push towards using these common formats a lot more, and why there's real need for tooling across the ecosystem to generate the data, to share the data, and to use the data automatically, because that's where we're going to get these real benefits. There's still plenty of open questions. There's lots of work to be done. One question is, what are the obstacles to obtaining SBOM data? As you go up your supply chain, in some ecosystems, in some corners of the community, it's going to be super easy, right? You run make with some noisy flags, or it's already built into your environment that you can go and pull in all the dependencies. In other areas, maybe it's more opaque, not just in the commercial space, but in different parts of the open source world. As you move across communities, we think there are going to be some obstacles. We want to be able to identify those and start overcoming them. How do we share SBOM data? This is the challenge. So the vendors are going to generate it. The customers are going to use it for the use cases and the benefits that we've talked about. What does the active transparency look like? In some cases, like for example, SWID tags, this is easy. The SWID tag follows the binary, so whenever you update the binary, you get a new SBOM, and so you can, your data always sits next to your binary. That doesn't work in every case. So for example, in embedded systems, that doesn't make as much sense. You can't be scanning your operational environment and trying to read this data off of, SCADA systems. And moreover, in a more service-oriented architecture, it's not clear how we're going to transmit this and make sure it's always up to date. It might be much more of a pull rather than a push approach. And perhaps the last thing that we want to be very careful of is this difference between vulnerability and exploitability. There are, depending on how you count them and who you ask, between 800 and over 1,000 different system calls you can make of OpenSSL. 2 of those call the heartbeat function that led to the heartbleed vulnerability. There's plenty of comfort that many people should have in using slightly outdated OpenSSL libraries just because they're not calling that right code. Or perhaps the way you call a piece of code, right? You're already sanitizing your inputs. So if you're using a function that doesn't sanitize theirs, no one can exploit it. That's a real challenge because we need to figure out trust and communication of that. And one of the things that one of the working groups is exploring is, can part of the SBOM actually convey data downstream from the supplier, from the open source group, or from a commercial vendor saying, yes, we know this component has a vulnerability. We don't think that that is exploitable. We've done these tests. And so for the time being, you should still feel comfortable using it. That's something that down the road ideally could be standardized, but for now we're talking about doing it just as a URL so that we can have that information to make it easier and save false positives, as well as making customer support cheaper. So what are the next steps? We already have lightweight drafts of these baseline documents that I've described, the what, the why, the how, and we have some of the summaries of this proof of concept. By late summer, we hope to have much more stable drafts, and that's when we'll want your feedback and your critiques, unless you're really excited, in which case you should get on board now. More on that on the next slide. After developing this minimum viable approach to SBOM, we're going to talk about extending the model. So right now, an SBOM is about keeping honest people honest, and making sure that we can identify vulnerabilities. If someone's actively trying to attack your supply chain, then it's much more important to have information about the pedigree and the provenance of the components that you're using, and to make sure the SBOM itself hasn't been compromised. So we need to have some cryptographic integrity. We want to focus on tooling, right? Again, this is something that shouldn't be done manually. How can we integrate this into as many build chains as possible? How can we integrate this into the vulnerability management tools that organizations are using today? And then finally, and this is where you all come in as well, is awareness and adoption. This is going to be coming down the road. And we think that what we want is to have this happen in a voluntary fashion before governments have to step in. The supply chain risks, as you probably know, are getting more and more headlines each day. And they're also, for better or worse, becoming more understandable. The risks are becoming more understandable to policymakers. When policymakers understand something, they try to do something about it. We think that market transparency is a solution that the market can help with itself, and get in front of regulators, so that even if they get around to requiring something or building it into contract language, you're already doing it. So, to recap, we've got third-party components, and we think that transparency can really change the marketplace. We see this in other areas, and there's no reason why transparency isn't possible in the software supply chain and won't have a lot of benefits. We've got an open process that's convened by a part of the US Department of Commerce called NTIA, and we've been focusing on the what's, the whys, and the hows. We would love your participation, so feel free to reach out by email, contact me on Twitter, or just Google, SBOM. These days, it's all I talk about, and so even mention it in a crowded room, and somehow someone will say, "Oh yeah, Alan's right over there." So I hope you can help. Thank you so much for your time.
Alan, that was great. Thanks. There's a couple things I want you to cover a little bit more here. On that healthcare proof of concept, is there any way people can find out about that project?
Very much so. So the NTIA website, which would have been a great idea if I had linked to this, if you Google NTIA SBOM, you'll be able to find a lot of documents that have been presented. That initial proof of concept was just completed a few weeks ago. So they only have produced initial findings from it. It was between a handful of device manufacturers and a handful of hospitals. One of the things that that group is dedicated to doing, in addition to very carefully documenting their experience, is they want to do another proof of concept. They want to say, here are the lessons learned. Let's build on the standards that the standards group is working on. Let's use the schema that the what group has been talking about. And so they're going to do another proof of concept, a little more organized, probably with a broader group, and to be able to demonstrate that even in a short period of time, both the producers of software and the consumers of software have learned. And I think that second proof of concept is going to be very powerful.
The other thing that you touched on was vulnerabilities versus exploitability, which even when you and I first talked, I made a note of that. That's an interesting concept.
It is one of the older debates in security. This goes back 30 years to talking about vulnerability disclosure and the debates we've had on that. There are a number of research studies that have tried to predict exploitability. And the simple facts are, if you look at the National Vulnerability Database, there are, tens of thousands each year. Only a small fraction of those get actively exploited in automated tooling that we can capture. Now, there are a couple of challenges with that metric. One, how do you determine which one you should be worried about? And two, if your threat model doesn't just involve the people hammering widely around the internet, the vulnerabilities are out there, which means an adversary that wants to be a little quieter could still be using them. So that's a real question on what you should worry about. But of course, also, software is complex. And, modern software is even more complex than traditional software. And so understanding when something is exploitable and isn't is a very hard problem to judge. And that's going to have to, in the long run, be a partnership, a risk partnership between the folks who make our software and those of us who use software, so that we can better judge that. Certainly, every product security team has a lot on their plate, and they're going to have to prioritize, do I address A or B first? And that means that some vulnerabilities aren't going to be at the top of the list, aren't going to be addressed immediately. And what transparency can do is help share that information so that we're aware of it. And in the meantime, vulnerability management is going to have to also reflect the limited budget of both software suppliers but software users, and help evolve to help organizations prioritize and say, okay, here's what you really have to address today, and here's the stuff that if you can address later, you can do that.
Excellent. Thank you, Alan. Always good to talk to you. I mean, this is an exciting thing for us because it's right in our wheelhouse and what we're trying to support. So very much appreciate you joining us.
I appreciate it, and I appreciate your leadership on this topic. And hopefully anyone who wants to get involved will reach out directly or reach out through you to get in touch with us at NTIA.
Sounds good. Thanks.
Thank you.